Thanks, Anjan, for the warm introduction. Very good morning to all. I am Taru. I work at Common Stack Foundation for Participatory Technologies, which really looks at building a public-centered digital public infrastructure for climate change adaptation in rural India. This particular piece of work has been co-authored by Anuradha Ganapati, a PhD scholar at University of Manchester, and Aditesh Vesik, who is the founder of the organization. So the tech stack that we are building, core stack, which stands for Combining for Resilience and Equality, essentially aims to bring the power of geospatial AI for climate resilience directly to the end beneficiaries, which in our case are the rural communities in India. So let's dive right into some of our insights grounded in the practicalities of building the system. And we'll also see how the very meaning of participation evolves through the design, deployment, and usage phase. So between 2022 to 2024, when we set out to understand how natural resources like land, water, and forests are managed by rural communities in India, we came across many such instances with water structures like wells and farm ponds being dried up, validating how rural India is the worst hit in terms of poor water security. Uh, if I'm not wrong, India has about 18% of world's population, but has access to only about 4% of freshwater resources, right? So, given this huge demand supply gap, sustainable and equitable means of managing water resources becomes very crucial. Yeah. Okay. Given this huge demand supply gap, the sustainable and equitable means of managing water resources becomes very crucial because rural livelihoods are heavily dependent on water. However, we found that participation in decision making may not always be equitable. Women and people from vulnerable caste groups might get sidelined. We also realized that even though geospatial science can make assessments for building water structures at a site more accurate, data-driven planning is not yet accessible to the community stewards or landscape stewards who lead climate action on the ground in rural villages. For instance, the consideration of, the picture that's shown here, the consideration of land features like lineaments would have pointed out that this is a poor site for farm pond construction, but it wasn't considered in the case that we encountered on the field, and it got a huge monetary investment with poor returns. Additionally, there also needs to be a shared understanding of operating within the ecological limits of the landscape so that we are not exploiting, let's say, groundwater more than we are replenishing it. And poor collectivization within the communities can, for instance, lead to such exploitation. Now, how does climate action actually take place in rural India? So there's a scheme called NREGA, National Rural Employment Guarantee Act, the biggest social welfare scheme in the world, which operates on a twin principle of employment and climate sustainability. So it enables bottom-up demand generation for natural resource management in rural India to promote the construction of durable intervention and assets for water security, making the communities climate resilient and also generating additional wages for them for the construction of these assets. But it does not directly translate into sustainability and equity-focused demands from the community. The landscape stewards, which I just spoke about, play a very central role in making that happen. They connect the government schemes to community needs through consultations, mapping of common resources, and their efforts are directed to achieve a collective decision making in the community so as to unlock sustainable and equitable management of natural commons. So the question that I want to probe is that can data, especially geospatial AI-based data, strengthen this process further? With the India AI Impact Summit going on, I think some of you might have noted that there were a lot of sessions on AgriStack or using geospatial AI for climate resilience. Some of my other speakers will also be talking about the use cases of technologies built for climate resilience. But the key question is, what potential does this entire paradigm of geospatial science hold for the landscape stewards on the ground who actually lead natural resource management. So, for a stronger accountability between the government and citizens, geospatial data-driven site suitability assessments can potentially help validate community demands, and the digitization of the entire process can allow people to build to hold the government decisions accountable. Similarly, there is also potential for geospatial data to provide landscape assessments in ways that surface the ecological limits of the landscape, the resource equity issues, so that we move towards cooperating with the land and each other, right? So keeping these values at the core, we launched Commons Connect, which is a mobile-based application facilitating data-driven participation and demand generation for natural resource management. It was piloted in 2023 and it's targeted towards these very landscape stewards. Right. So what does the tool really do? Why are we discussing it here in the context of AI and participation? So I'll give a brief overview of the workflow. The landscape stewards start with resource mapping. So essentially going from village to village and mapping the state of existing natural resources like wells, water structures on the ground, their health, the socioeconomic status like livelihoods and caste identities of the communities that are dependent on that resource. They are then shown very specific geospatial layers such as change in land use and land cover, change in water balance and cropping practices, which guides them, which guides the decision that they take towards what interventions to demand from the government. And finally, it's generated into a detailed project report, which they can then submit to the higher authorities for review and approval. So, what we see on the screen is an example of how geospatial AI-based data can build a shared understanding of natural resources in commons. So, the data on cropping pattern on the left-hand side can trigger conversations on groundwater use and reveal an insight such as areas with higher cropping intensity also being areas where people are noting that the depth to water in wells is worsening over the years, right? Another example that comes to my mind is the app showing dried up water bodies to people so that in a way nudging them to revive it or to propose another water structure on it because it has a good water holding capacity. People can also visualize their hyperlocal data, such as caste-wise access to water resources overlaid on cropping pattern. So here in the image, we see a bunch of settlements or colonies in a village, which are often segregated based on caste. So one caste identity would be clubbed in one settlement and so on. We see some of the settlements having good access to these water structures, some with very poor access. Similarly, the yellow icon that you see there corresponds to structures that need maintenance. So during community consultations, I've noted that issues linked with equity, with poor maintenance of resources and low awareness of relevant schemes get surfaced. What I also noted in the field visits was that it's generally difficult for these landscape stewards to trigger conversations on resource equity because either members from the vulnerable caste groups are absent in the meetings or even if they are present, they are unable to voice their opinions. But after using Commons Connect, a member from one of our partner organizations mentioned that the mix of geospatial and field survey data shown on the app acts as evidence and speaks for these vulnerable caste groups. So, for example, this is a settlement with a higher proportion of a caste community that's typically marginalized across income levels predominantly. They have access to just 2 wells and their land cover is predominantly forest. And this is a settlement with a relatively better off caste community dominance, access to multiple public and private resources, and they're able to do cropping twice in a year, and number of crop cycles is an indicator of income levels. So once this data advocates for members from tribal communities, which are historically marginalized, they're able to voice their opinions in a much better way during planning discussions. Additionally, the app also provides decision support for assessing the suitability of a site for groundwater recharge and harvesting structures so that communities can account for a technical evaluation while demanding something along with their own knowledge because typically This knowledge is only accessible to technical assistants that are employed by the government. Um, and additionally, they also have data backing up their demands when they present it to the higher authorities. Finally, all these proposed demands linked to soil and water conservation, livestock management are integrated into a detailed project report, which can then be shared with the citizens and presented to government authorities. So, trust and accountability can improve through this digital record keeping because we are saying that whether the demands get approved or not, the committee now has a track record, right? That these are the demands that we submitted, so they can follow up year on year if they have a record. There's a due process that's followed. It's geotagging, community consultations, demand justifications, generation of digital reports. One of the participants also told me um, how the community now entrusts her with stewardship roles since Commons Connect enables her to see them as decisions maker and not just data providers, which is very, very important when it comes to how we look at participation, right? In her words, when we show people data on changing land cover or topic practices and what happens, it adds a flavor of preciseness to conversations on climatic changes and um, people are becoming more aware of assets that they can demand because the app also shows a list of what all can be demanded. Moreover, when their data on livelihoods and resource access is converted into visualizations over geospatial maps in real time, it gives them confidence that we are here to talk about problems and solutions rather than just a tokenistic collection of data. So what does participation mean in the context of Commons Connect, which integrates geospatial AI analytics with localized data for natural resource management? So what I just described in the previous few slides is just participation through AI, where the geospatial data strengthens participation between different stakeholders. And now I'll be talking about participation in designing this system. So what processes we followed in designing Commons Connect. So we ensure that all our team members, whether engineers, researchers, founder, designers, all of us go to the field so we all understand the way of living of communities that we're working with. We conducted multiple field visits between 2022 to 2024 to understand how NREGA functions, what is the role of landscape stewards, what might enhance climate sustainability and resource equity, what is the current maturity of using geospatial AI on the ground. And ever since we launched our app, we have been holding regular feedback sessions and iterating over our design, fixing bugs, hand-holding partners as they integrate the tool in their workforce. For example, we've organized about 3 workshops bringing together civil sector organizations, technologists, public policy researchers to take this tech stack forward. We also hold these monthly community of practice sessions to enable consistent cross learning between on different themes linked to climate action in India. Our general flow is testing, piloting, and scaling. So we first test the relevance and potential of Commons Connect at a location along with an NGO embedded there. We then pilot the tool and accordingly plan for its scale up in that location. As we noted earlier, the communities are feeding their localized data such as their demographic details, resource ownership and dependency on Commons Connect, and it's the integration of this primary data along with the secondary geospatial data that drives the decisions. And this is important because there are limits to pre-computed data and the algorithm won't be able to detect the health of a well and whether it requires maintenance. It also doesn't know which communities are depending on a particular well. Similarly, we take community inputs to enrich geospatial data. We might be able to detect computationally that there is a farm at that location. But has there been a shift towards more cash crops, for instance? Is something the community can tell us best. And a core feature of Commons Connect is to allow the community to contest the data shown, which is very important. We acknowledge that data can be erroneous at times, and we rely on community to provide us ground truth data. The stewards who are using the app also contest the accuracy of data shown. For example, an area that our algorithm marked as double cropping might actually be barren. So we acknowledge the limits of the data and people using the app know that they need to prioritize their own knowledge over what is shown on the app. So there are certainly limits to what we want and don't want AI to do. We don't want to reduce participation by automating the entire workflows. AI in our context cannot become a scapegoat to avoid accountability. We also don't want the communities to foster blind trust on AI. So we are not giving them an end-to-end system of here's the data and here is what you should do. Their inputs are integrated at every phase, right? Essentially, we are building towards more participation and less AI. We are going to capture it in a place. And yes, we've definitely had a lot of challenges in building core stack. So participatory design by nature is complex. A lot of time and labor is invested by the end users. We need to continuously manage their expectations because there are inherent limitations of technology. Continuous adaptation of the tool to diverse needs of the users is also difficult because the landscape of different states vary, right? Their requirements and expectations vary. The landscape steward, who's an intended user, is also not just one persona. Their role differs in terms of thematic area they work on, the prior experience working with the NGO, financial incentives provided to them, right? Similarly, we also need to engage in building capacity of not just using the app, but also making sense of geospatial science. But yes, we have been able to steer through most of these challenges given the thriving collaborative network that OpenStack is a product of. So we have about 50 plus implementation partners across Odisha, Jharkhand, Bihar, Rajasthan, Karnataka, and Gujarat. A bunch of knowledge and research partners, and we have presence of over 450 villages where Commons Connect is currently being hosted. Yes, I think that's done. Thank you so much for this. Thank you.